Perfect. Hi. Okay. So we are on chapter 6. This is lesson 5, and it's the first day. So this is going to be, day 1 and day 2. And this is my video notes for the chapter. So day 1 is just the beginning, part A, So we're doing transformations of exponential functions. Now we know that we've been given the past, 2 weeks a graph where I have something raised to the x power. And the x is where I plug in a variable. So now I'm going to add to this and say a transformation means a shift. So I'm going to have this graph, a to the x power. A can be anything. A could be 1/2, it could be 2, it could be 3, it could be 1/3, anything. But I want to be able to move this graph around. And so we're going to shift it, and it's called the transformation. Now, this exponent here, x, I can add a number to it. It's always going to be a 1, a 2, a 3. I would never put a fraction up there. And the h tells me to go left and right, and it's the opposite sign. So my h, whatever number it is, I have to move my curved graph the opposite direction, left or right. And that's going to be in the exponent. So then there's another number. It's a large number, and it's at the end, and I'm going to call that k. And a k tells me to go up or down. And the sign is what it is. So I'm going to write down about 4 different samples, and I want you guys to tell me what's going on. So I'm going to do y equals, and I can do 1/2. Why not? 1/2 to the x plus 3 power. Tell me what the 3 means, please. Someone in class. Left 3. Good. That's easy. Let me do another one. What if I had y equals 2 to the x plus 6? 2 raised to the power of x plus 6. Yes. Good. I probably should have done a minus sign, but all right. I can also use f of x instead of y. Here's a third example I'm going to give you. F of x equals 3 to the x power minus 1. I don't ever say that that is 2. You never would graph that and be like, oh, look, 3 minus 1 is 2. No, no, no. Arturo, what were you going to say the minus 1 means? Down 1. All right. Okay, ready for a challenge? 2 to the power of x plus 2 minus 3. I doubled up on you. I gave you an h and I gave you a k. So I can even do the arrows. If you forget and you want to do these arrows, go for it. Yes. Left 2, down 3. So good. Good job. All right. And we're going to do describing words, and we're actually going to graph a little bit of this. Okay. So the typical table of values. Let's start with example 1. The typical table of values means that I would have like 2 to the x power. Well, remember when I plug in 2 to the, and we haven't done this very much, 2 to the negative 2 power, that's 1/4. 2 to the negative 1, remember how that was 1/2? 2 to the 0 was 1. So this is the parent function table of values for just a typical 2 to the x power. 2 to the first power is 2. 2 to the second power is 4. Okay, you guys, I'm now putting a plus 3 at the end. That means that I'm going to take this 2 to the x and I'm going to add 3 to it. So that means that I'm going to look at this 1/4 and I'm going to say, what's 1/4 plus 3? 1/4 plus 3. It's a quick and easy answer. What's 1/4 plus 3? You just put them together, guys. 3 and 1/4. So that would be if I added 3. This is my k, right? K goes up and down. What happens next section of my table of values? What if I do minus 3? 1/4 take away 3. 25 cents take away $3. You have 25 cents, 1/4, and I say you owe somebody $3. How much in debt are you? 1/4 minus 3. 25 cents take away $3. How much in debt are you? No? $2.75, and it's negative in debt. Minus 2 3/4. 75 cents is 3/4, right? Okay, now I'm going to go and do this with 1/2. This would be where the ordered pairs would be if I did a K. 1/2 plus 3. Quick, what's 1/2 plus 3? 50 cents plus 3. 3.5. Next column would be 1/2 minus 3. 50 cents take away $3. 50 cents take away $3. Negative 250. 250 is negative 2.5. Now it gets easier because we're done with fractions. 2 to the 0 power is 1. What's 1? Let's do this one. 1 plus 3. 4. What's 1 minus 3? 1 minus 3. Negative 2. All right, 2. So now this is my answer. 2 to the first power is 2. Let's do 2 plus 3. 5. 2 minus 3. 2 minus 3, negative 1. Last row, I have a 4 as my result. 4 plus 3. 4 minus 3. Easy stuff, right? If I graph these ordered pairs, it would be negative 2, comma 3 1/4, negative 1, 3.5, 0, 4, 1, 5, 2, 7. That would be for this graph. If I graphed this last one, it would be negative 2, comma negative 2 3/4, negative 1, negative 2.5, 0, negative 2, 1, negative 1, 2, positive 1. Okay, let's go to the next example. Okay, this is crazy. Look at what I got. An a times b to the x. This is what the formula is. The equation is 5/12 times 4 to the x, but it's translated up. Up means k, right? So I would write my equation, but I'm going to put a plus 5.98 at the end of it. So I write this as is, 4 to the x. But if I'm going to go up 5.98, I'm just going to put a plus sign, 5.98 at the end. That would be my k. So I just did with you the k, which is up and down. Now I'm going to talk on example 2 about h, left and right. An h, it says, compare the graph of 2 to the x minus h, which means this black line here, with the graph of 2 to the x, if h is a positive number, h is greater than 0, positive number. H is greater than 0. H is a positive number. What effect does h have? H is going to move. H moves my graph left or right. Okay? And you have to do the opposite sign. Super important that you remember that. Okay, so if h is a positive number, like let's make one. 2 to the x, and I'm going to make it a positive, plus 3. This means 3 left. Remember, opposite sign. 2 to the x plus 2. 2 left. Opposite sign. So I literally would be drawing. Let's graph this one. Every ordered pair, I would just shift 3 to the left. 1, 2, 3. Every ordered pair, just move 3 squares to the left. 1, 2, 3. Every ordered pair, 3 to the left. 1, 2, 3. Every ordered pair, 3 to the left. 1, 2, 3. So 3 to the left would be this blue line here. Arrows at the end of both. That's what it would look like if I shifted it 3 to the left. And I'm just counting squares. I didn't even make a table of values. Part B. Compare the graph of 2 to the x minus h when h is negative. Negative number. Here we go. 2 to the x minus 1. What happens? What does this minus 1 do to my graph? 1 right. 2 to the x minus 2. How about someone else that hasn't talked yet today? You guys should know this by now. 2 right. So the only thing you have to think about today is an H and a K. The H is the opposite sign. Okay, let me turn the page. There's some word problems, but we're going to talk about those tomorrow because it's just putting it into real life situations. So here's the deal. You have attached in this packet 6.5A classwork, day 1, and then the next page is going to be day 2. So on day 1, I am giving you, this whole page is day 1. The front and the back is going to be what we're going to do for practice. The front and the back. So they're not really even numbered. Do you notice that there's not numbers? But you're going to do the front and the back of this first page that says 6.5A classwork. We're going to do the front and the back right now. And I might as well just do the video and keep recording. Okay. A, B, C, and D. This is a K. 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 All of these mean that I'm going to go up or down. And I do the actual number. Like, there's no changing of sign. So I want you to write in words. For A, B, C, D, am I going to go 2 up, 5 down, 3 up, 6 down? What am I doing with these numbers? It's a 2 and a -4 and a -1 and a +1. So write the words like up 4, down 4, whatever. Go ahead and write those in for A, B, C, and D. You're ready? Up or down? Up 2. That's what you write. up 2. Okay. I have 4 different colors that I can use, and I don't really know if you have that. Probably not. But what I'm going to do is I'm going to graph all 4 of these, A, B, C, and D, and you're not making a table of values. You're literally going to just draw the original parent function, 3 to the x. I'll do that in blue. So here we go. We're all going to do this together. Graph the parent graph, y equals 3 to the x power. Here's the table of values for y equals 3 to the x. Let's just do -1, 0, 1, 2. Okay. When I plug in -1 for my exponent, I would get a 1/3. 3 to the 0 equals 1. 3 to the first equals 3. 3 squared equals 9. And so I'm going to graph those. -1 comma 1/3. You used to always start at the origin. -1 means that I'm going to go 1 to the left and up 1/3. Not even to the next box. So just a little bit above. 0 comma 1 is the y-intercept. One comma 3 is my next. Over 1, up 3. And 2 comma 9. Over 2, up 9. So this is my parent function. Remember, it never touches the asymptote. This is 3 to the x. And I'm going to put a little 3 to the x so that I know that that's the label. Then I'm going to do A, B, C, and D. I'm going to do A in black. B I'll do in red. C I'll do in purple. And then, green? I don't even know if you'll be able to see green. Okay. So, if you don't have colored pens, then you're just going to label every line. And that's going to be easy too. So black. You are just going to look at these dots and you are going to go, what'd you guys say, up to? You're just going to shift every dot and redraw 2 boxes higher. So if I have this 1/3, everybody with me? This 1/3, if I go 1 box up, that means that I'm at this part of 1/3. And then I have to go, you said 2 up. So my new black dot is going to be right there. Exactly 2 boxes straight up. And it's not even on a corner. It's in the middle, you know. Next. 2 up on my y-intercept. Here's my y-intercept. Just go 2 up. 1, 2. Let me make a dot. At this dot, 1 comma 3, go 2 up. And 2 up on the other one. So I just moved 2 up because you said on A, the K meant up 2. Now, please notice that this is going to be my new asymptote. And so this is 3 to the x plus 2. The black one. So I just did black. Now I want to do red. Red means down 4. Are you guys with me? Am I going too fast or slow, or how is it? Okay. You're going to go down 4 from your parent function. My parent function is blue. So I'm going to make a movement of 4 boxes down. Every dot, blue dots, go back to your original parent function. 4 down. 1. Now I'm in the negatives. 2, 3, 4, like right there. And then I'm going to go to the next dot, the y-intercept of my parent function, my blue original, and go down 4. 1, 2, 3, 4. Make a dot. And the other one, go down 4. 1, 2, 3, 4. And this last one, way up here, blue original. 1, 2, 3, 4. And now my new asymptote is going to be at like -4. 3 to the x minus 4. Red. Purple is down 1. Down 1. From my blue parent function, my original, make dots down 1. And now they're going to start like meshing into each other, so you have to be really careful. They're all going to kind of get really close at the top. 3 to the x minus 1. Okay? Lastly, green. Up 1. And do the last one, up 1. From the parent function blue, go up 1. Oh my goodness. Three to the x plus 1. Okay. So I'm easily just going up and down, up and down. I could do the same thing if I had an h, if I had a number attached to my exponent. I could go left or right. But that's what we're going to do tomorrow. We're going to like merge them all into one. So this front side was just using k. The back side is h. So you're going to do, and I am going to stop the video and have you actually do this by yourself because you need to do something by yourself. I can't do it all for you. So this is going to be left and right, h. Opposite sign. Okay. So